Welcome back to my channel Into the Oracleverse, where we learn about Oracle SQL, PL SQL, and Apex. Don't forget to hit that subscribe button. In this video, we will be preparing Oracle 26AI database for ONNX based vector search. This is a continuation of one of my earlier videos where we have installed Oracle Apex, Oracle database, and ORDS within a same Docker container. And now we are going to enhance it a bit more so that it supports similarity search, semantic search. In this particular video, we are not going to call any external AI service. Rather, we are going to run an ONNX embedding model inside the Oracle database, and we are going to use it for semantic search. Let's get started right away. I'd suggest you to watch one of my earlier videos where I have walked you through the setup of Oracle 26AI database within the Docker. So ONNX, what is ONNX? So this ONNX is Open Neural Network Exchange. So this is a standard format for the machine language models, uh, which is currently supported in Oracle. Right now, Oracle database allows these models to be present within its ecosystem, and these models can be utilized to convert the text to embeddings. So I have a small representation or a small example of how this semantic search works. So initially user would be entering their relevant data, and with the help of ONNX models, we would be converting these text to vector embeddings. And initially we used to store these vector embeddings in a separate vector database. But in Oracle 26AI database, so we have a separate data type called vector to store all these vector embeddings. When a user provides a query like find tall volcanoes and things like that, so this text would be converted into vector embeddings using the same ONNX model, and this particular vector embedding would be searched against the existing vector embeddings, and then the results which are closest to this particular text which user has entered would be displayed. We would be able to use the normal SQL queries to retrieve these values. Here, the text is find tall volcanoes, and so based on the user's input, so right now we would be able to fetch this particular part. What are all the benefits that we have here? We won't have to share these data with external AI service to change or to convert this particular text to vector embedding. Rather, we'll have a particular model within the database which would do all these things. So this enhances security, and it also increases the performance of the conversion. And then we would be able to use the native vector data type to store these vector embeddings, and we would be able to use normal SQL queries to fetch the relevant results based on semantic search. Let's jump directly into the setup mode. I'll connect to the database as system. It has the relevant privileges to create directories for me. So first I'll be creating a directory object. So this directory is just a representation of an actual physical directory which would be present within databases, a physical file structure. So now I have created one called vector models, which is referencing to TMP vector models. So this particular directory has not been physically set up yet within the database, and hence I'll have to create that now. But before that, I'll have to provide read-write access for this particular directory to my schema of interest. So I won't be using this schema to do the demo. So I am giving this read-write access on this particular directory to demo schema with which I'll be demonstrating it. So now that's pretty much it here. The next step, so here we are just creating the directory vector models, which is a reference for an actual physical location within the database. So this particular directory is referenced with this particular directory object called vector models. So now we'll have to create this particular directory within the database. So to do that, I'll have to access the containers shell. So right now my container is up and running. So I'll be sitting from here and I'll run this. So now I'm inside this particular shell. So now let me connect as Oracle user, and the password is the same Oracle. And now I'll create the directories. So this is the code to create the directory. Yeah, and I'll be pasting this blog's link in the description. So the particular directory has been created. Now let's navigate to that particular directory. So now let me copy this code. So let us navigate to this particular directory. Yes. And now the next step is to download the ONNX embedding model. So I have a particular model called mini LM. So this is lightweight, and yeah. So for demo setup, I'll suggest you to do the same. You can download the same thing. So now it will take some time. I might fast forward here. The model has been downloaded. So we have everything set up. We have created a particular directory object which references to the actual physical location where the models are present. And we have created the relevant file system as well. And then we have also downloaded the relevant ONX model. So now we would be able to proceed with the help of Claude MCP in a much faster way. We would be able to do that with SQL codes as well, and I'll be covering those things in a different video. So here I'm going to use my Claude MCP client to do that. In one of my previous video, I have walked through how to set up Claude MCP, the SQL MCP with SQL CL MCP and Claude Desktop and Oracle 26 AIDP. So I have created this particular interface where right now I have established this particular connection where I would be able to use the SQL CLs or access the SQL CLs MCP through the cloud client, which in turn looks into my database or has access to my database or to the connections that I have specified. So yeah, first let me connect with the relevant demo schema. I'll ask it to list all the connections. It has listed all the connections. So let me connect with the demo schema now. In one of the earlier videos, there was some issue with the connect tool. I have just updated SQL CL to the latest version, and now it got fixed. So now I can see that I have made a successful connection with the demo schema. Now I can just let Claude MCP to do the rest of the job. I also did a small sanity check to confirm which schema I am currently in, because this particular part, this is just the name in which we have saved this particular connection. So it is always good to verify which schema we are in. So I know that my current schema is demo schema. Here, I have drafted a particular prompt which would provide relevant insights to the Claude client, the Claude desktop, and I have also asked. So here you can see that I am asking it to connect to the demo schema, which has already been done, and then I am asking it to load the current ONNX model, which is present in vector models directory, and I am asking it to create an animals table with provided columns. And I have also provided the dimension for the vector data type. And then I have also asked it to add some sample data for me with some uh, with some specifications so that I can test the SQL part as well. And then I have asked it to generate the actual vector embeddings using the loaded ONNX model. And I have also asked it to show me the search queries to demonstrate or to actually confirm that the semantic search is working properly. So I just have to see, it has listed all the steps that I have to perform. So this is the power of MCP. So this would help us to accelerate the pace at which we develop things and at which we try out new things and stuff. So here I can see the actual queries, but here the vector embeddings were created by the model itself. It was not created with the ONNX because of a table space quota issue. So now I'm going to increase the table space quota. So let me just copy this. So I'll have to connect to the database via SQL as system. And so the demo scheme has been altered right now. So let's try this again. Let's see if this works this time. So, yeah, so I'll have to enable the auto extend as well. Here you'd be able to see that several artifacts would be created based on the need simultaneously. So let me quickly do this and then let me come back. There were a few more data space related issues, and hence, yeah, I had to run this particular part where I had to extend, auto extend this particular data file as well. So now, since that is done, here you can see that the model is loaded, and here now the same table is being dropped and recreated again with the real embeddings from the ONNX model. So these are the advantages that we have with the MCP connection. So yes, here you could see that the ONNX model is generating the real vector embeddings. So this time it is not generated by the Claude desktop. Rather, it's being done with the done by the ONNX model, which is installed or which is present within Oracle database. So it's working as expected. So you could see that all the examples are being passed. See, now we are able to see that in action. So with that particular data setup of animals, so we are able to get all the relevant values in the right way. So this is the power of vector search, and this is so these enhanced capabilities in Oracle 26a database allow us to have this particular model within our database and then do all these relevant things. So right now it's working well. So that's the end of this particular demo. In upcoming videos, we'll see how we can use this particular vector search in Oracle Apex applications. Thank you so much. Drop in your thoughts in the comment section, and for more videos like this, subscribe to Into the Oracle World.